It's a memory-based question of GATE 2023. The question is from linear algebra and it's a question of 1 mark. The question says that T is a linear transformation from R4 to R4. The kernel of T is given by the equation, this one, and rank of T minus 3i is given as 3. Okay, and we have to find the minimal polynomial of T. So since the question is of 1 mark, we will do it quickly. Okay, let's see a result. The dimension of kernel of T minus lambda I is equal to the geometric multiplicity of the eigenvalue lambda. Okay, so we are given that the kernel of T is given by the equation this one. Okay, so there is only one equation and there are 4 variables, so there is 3 variables, right? So that means the dimension of ker T is given by that free variables, and there are 3 free variables, so dimension of ker T is 3. Okay, and what this result says, the dimension of kernel of T minus lambda I is geometric multiplicity of lambda. So can you put 0 in place of lambda and say the dimension of ker T gives the geometric multiplicity of the eigenvalue 0? Okay, so dimension of ker T is 3, that means geometric multiplicity of 0 is what? 3. Okay, and the statement says that rank of T minus 3i is 3. Okay, so since it's a linear transformation from R4 to R4, so by rank nullity theorem, if rank of T minus 3i is 3, then nullity of T minus 3i is what? 4 minus 3, which is 1, right? So nullity of T minus 3i is 1. And what is actually nullity? Nullity is the dimension of kernel of T minus lambda I, right? So nullity of T minus 3i gives the geometric multiplicity for the eigenvalue 3, right? So what is the geometric multiplicity of 3? It's 1. Okay, so how many geometric multiplicity totally you are getting for the eigenvalue 0 and 3? So you are getting the geometric multiplicity for 0 is 3 and geometric multiplicity for 3 is 1. So total geometric multiplicity is 4, and it's a transformation from R4 to R4, and you are getting that the geometric multiplicities are 4. That means you are getting 4 linearly independent eigenvectors, right? So from there you can say that the matrix is diagonalizable. Okay, because you know the result that if a linear transformation from Rn to Rn you are getting n linearly independent eigenvector, then the matrix is diagonalizable. Okay, so if a matrix is diagonalizable, then the minimal polynomial must be in linear factor, right? So from these, which option have the linear factor? Only the option A, 1, right? So clearly from here 1 is the right answer. Okay, so uh, let me show you another approach. Okay, so do you know the result that if a matrix is diagonalizable, then the algebraic multiplicity and geometric multiplicity are same? Okay, okay, and here is a hint that algebraic multiplicity is always greater or equal to geometric multiplicity, right? So okay, so if algebraic multiplicity is greater or equal to geometric multiplicity, so the algebraic multiplicity for 0 can be what? Either 3 or 4, right? But 4 cannot be its algebraic multiplicity because it's a linear transformation from R4 to R4, and 3 is also an eigenvalue. So the only possibility for algebraic multiplicity of 0 is 3, and the geometric multiplicity of 0 is also 3. So algebraic multiplicity is equal to geometric multiplicity for 0. And also for the eigenvalue 3, algebraic multiplicity is equal to geometric multiplicity. Hence from there also you can say that it is diagonalizable. Okay, so if you have any problem understanding this concept, please comment me. I will definitely give you reply. Okay, so I will see you in the next video, but for this time, okay, take care.